Okay, I think we'll get started now. Thank you everyone for joining us and welcome to our webinar, Taking the Sting Out of Mildness Testing. My name is Richard Scott and I'm editor of Personal Care magazine. Joining me today is Carol Treasure, founder and CEO of XCellR8. Just turn the page so you can see everyone. XCellR8 are the only 100% animal-free or vegan testing lab globally. XCellR8 offer regulatory safety testing as well as efficacy testing for personal care, cosmetics and chemical industries. Also speaking today is Stewart Long, Managing Director of Cutest. Cutest are a full-service human volunteer CRO for beauty care and healthcare companies. They have been operating for 35 years in the industry, so are one of the longest established globally. But before we start, I'd like to draw your attention to the chat icon, which some of you have seen already. It's in the shape of a speech bubble, hopefully I think to your right on the screen. This allows you to put forward questions to our speakers during the webinar, and we'll have some time to go through as many questions as we can at the end. So now I'd like to hand over to Stewart, who will first give an overview of what the webinar will touch upon. Thank you.
Thank you, Richard, and I'd like to say welcome to everybody who's taken the time out to join this webinar with Carol and myself today. We appreciate you taking the time. What we'd like to do during this time is to share with you the project that we've been working on for the past 2 years. We'll be sharing some of the data that we've generated and explaining the rationale behind why we put this piece of research together. So the questions that we want to go through in today's webinar are: why does the industry need a new model to predict mildness to skin? We're going to cover a little bit about what the existing methods are and what their limitations might be, and then how we worked on those and optimized those to create a new model, which we're presenting today, and the correlation between in vitro testing for skin irritation and in vivo testing for skin irritation. And then we will share towards the end some real-world applications. So the first slides will be about establishing the model and the correlations, and then we'll share with you some really interesting data on real-world applications of personal care products, including some comparison data between soaps and facial cleansers. So that's really what we're looking to cover today.
So hi everyone, it's Carol here, and just like to echo Stuart in saying thanks very much for joining us for our webinar today. It's great to have you all here. And I'd like to just set the scene a little bit by thinking about why we need to have a new method to predict skin mildness. And this is really primarily being driven by the fact that there's an increasing demand from consumers for milder and milder products. And in line with that, companies are finding that there is an increasing demand to substantiate marketing claims that are going to differentiate them from the rest of the market. So I think this was a primary concern for us. And also keeping in mind that existing animal data seems to be used to validate in vitro methods on a regular basis. That is the gold standard. And what we wanted to do was to move away from that quite archaic approach and to make sure that we could validate our in vitro methods against real human data, which is much more scientifically relevant to the cosmetics of today. So we've been working on this research project together with Cutest, as Stuart said, for the last 2 years. We'd like to thank Innovate UK for the funding for this work, which has made it all possible. And the aims of the work were to firstly optimize in vitro and in vivo test methods, so to make sure that they were sensitive enough to detect very subtle differences between mild formulations, and then to assess the predictive capacity of those tests, and as Stuart mentioned, to look at some real world applications. So to set the scene, I think it's quite important just to think about existing methods for skin irritation testing. And in vitro, this currently happens at a regulatory level around the world using three-dimensional skin models. And the picture that you can see on the right-hand side is a cross-section through a reconstructed human skin model, showing that it has really close morphology to real human skin in vivo. And what happens is that ingredients and products are applied directly to the tissue surface. So it's providing a really good model of what happens in real life exposure to cosmetics. But one of the drawbacks is that the standard OECD test guideline only measures a single exposure time, and it gives a straightforward yes or no answer whether the ingredient or formulation is irritating or not. And it doesn't actually go into how irritating that item is. And for more sophisticated approaches today, we need to know how irritating is that item, not just whether it's an irritant or not. So we've moved on from that and looked at more sensitive approaches. And for some time now, there has been available an ET50 method. This is available from Matec Corporation, who have developed one of the skin models that's in regular use. And this measures cell damage over a time course rather than just a single time point. And as a result, we're able to classify items as severe, moderate, mild, or minimal or non-irritant. And to calculate an ET50 value, which is the time taken to reduce the viability of the cells in the skin model to 50% compared with untreated controls. So those values then allow us to place items into a rank order of irritation. But there were still some limitations with this methodology because it went out to a time of 18 hours and we wanted to look at something even more sensitive. So this is just an overview to start by looking at the methods that are currently available.
So in looking to compare the data that Carol and XCellR8 were going to generate for the in vitro model, we were looking to choose a relevant in vivo irritation model. There are several ways that irritation is measured in vivo, including the dermatologist assessing the skin in real life conditions or large panels of home use of products. But we wanted to look at patch testing because it's a controllable model. We can apply standard doses for standard times, and the assessments are well established and have been since the 1950s or 1960s. And patch testing, for those who are not familiar, uses the principle of maximizing the exposure of the product to the skin by occluding it for a period of multiple days, and it can be up to 14, 21 days. And the idea is that it's a very sensitive way of identifying ingredients or products which might be even very weakly irritant, but when used regularly by large numbers of people in the population, could lead to significant numbers of people having reactions to products. And of course, that has a potential impact on brand integrity and reputation. So it's a well-established, very sensitive method. Our clients tend to choose it where they're looking at critical applications, so baby care products, facial products, personal hygiene products, so where they want a good safety margin on the likelihood of irritation for their products. And of course, it's used to support claims including dermatologically tested, suitable for sensitive skin or eczema-prone skin, because we can choose the panel of volunteers with particular types of skin and make sure that products are not going to cause irritation issues, even for user groups with unusually sensitive or easily irritated skin. So that's the principle of patch testing.
So we've provided a brief overview of the methods that are currently available, and what we wanted to do next was just to move on to talk about how we've optimized these methods to make them more sensitive to look at skin mildness. And so in terms of the in vitro test, What we did in this project was to develop an extended time point test using the 3D in vitro skin model and looking at the irritancy of a range of ultra-mild items over an extended period of 48 hours. And so we used initially a range of surfactants to evaluate the model, because we know that surfactants are very commonly used in a very wide range of cosmetic and personal care formulations. And we kind of knew what to expect in a way with surfactants, so we wanted to use that as an original validation. And we determined the ET50 values of those, which will show you the data in a moment. And then we used that to develop a prediction model linking the in vitro data to the in vivo human skin patch test. And then we went on to create a database of industry-leading ingredients and formulations, which can be used for companies to benchmark their own products against to see how mild their ingredients or their products are compared to the industry average values. So this slide just shows an overview of the in vitro method. We applied the different surfactants to the surface of the skin model for different time points up to 48 hours. We had a negative control which was not treated. Everything was done here in triplicate. And we had a positive control, which is a non-ionic surfactant called Triton X100. And the measurement, the output of this test, is based on the metabolic activity of the cells, and that's indicated by the conversion of a well-known dye called MTT. Now that is actually the same detection method that is used in the standard regulatory skin irritation test. So we wanted to make sure that we were compatible with those methods as well. And then the output, as I've said before, was the ET50 value. And then we compared that with the in vivo information.
So when it came to the in vivo testing, we wanted to understand the following factors. How well does patch testing discriminate really mild ingredients and products? As I said, it's been used for 40, 50 years or more. But this was a great opportunity being funded by Innovate UK to really systematically look at modern ingredients and modern formulations and see whether we can discriminate even very mild products. So that was a good opportunity for us to look at that. We also wanted to understand for these very mild products whether the standard method, which is our expert nurses who've got a minimum of 10 years of experience of grading erythema and irritation on skin, how they compare to instrumental methods, so measuring the redness, the erythema of the skin, measuring skin temperature as a way of looking at how irritated the skin is. And of course, how well does the human volunteer testing correlate to the in vitro irritation testing, which Carol's just been describing? So they were our main objectives from the research. This is a slightly complicated slide at first glance, but I just want to explain why it's important to consider how long you apply products to the skin for before you make an assessment about whether they are potentially irritant or not. The graph on the left, which has the red box on it, shows a real patch test that we performed for a client some years ago of 4 products. And you can see that at the time course of 2 days, which a lot of patch tests, 48-hour single application patch tests, are performed in the cosmetics industry, all the products would have passed and been shown to be non-irritant. However, as the patch test evolves and we keep applying the products for several days, up to 14 days, you can see that actually 3 of the products, A, C, and D, would be unacceptable to be released onto the market for consumers. And this is why it's really important to understand the sensitivity of the method that's being used and whether you're actually generating useful data or you're just generating a report which doesn't tell you the real impact of products in the market. And the graph on the right just summarizes the number of people for each product who suffered a significant skin reaction. The other aspect of patch testing, which is sometimes overlooked, is that as well as looking at just the redness, which is the primary endpoint, we can also look at other consumer relevant issues such as spots, papules, scaling, and itching that a product might cause to the skin. So we get a wealth of information from this. And these are the sorts of things which consumers often report in the market where they have problems with a particular formulation. Now, as I said, there are lots of different ways of doing patch testing. So for this research, we tried to standardize as far as possible on a protocol where we did 4 applications of the product under occlusion, and we examined the skin over 5 days, so including the day after the product was last applied to the skin. There are some variations, as you'll see, depending on the products. And we compared clinical scoring to erythema, so redness, and skin temperature measurements as well. And as Carol's already said, the first experiment we wanted to do was to take well-known surfactants of varying recorded irritancy potential and see how the two systems compared in vitro versus in vivo to make sure that we had a legitimate scientific method that we could employ. So for the first experiment, we used 3 different cohorts of volunteers to look for reproducibility. And as I've already said, we did clinical scoring, color measurements, and the data, because there's a lot of lines on the graphs which are coming up in the next few slides, the data are presented without error bars, just for clarity. But we have indicated where there's a statistically significant difference with an asterisk. So just for clarity of viewing the images.
Okay, so we've talked now about the different methods and how we optimize them for this project. And now we'd like to show you some data. And this first slide shows the initial evaluation of the test using 4 very well-known surfactants. Those are SLS, SLES, CAP-B, and then also a novel biosurfactant. And biosurfactants are really coming to the fore now in the market, and many of them are marketed as particularly mild, and they're more expensive than their traditional counterparts. So we think that an important application of this work is looking at how mild those biosurfactants actually are. So for this first experiment, we created these profiles, and if I just talk you through what these graphs are, because you'll see some very similar ones in the upcoming slides. And on the vertical axis, you can see the percentage of viability of the skin cells in the skin model. And that essentially is a measure of damage to the skin cells over time. So as you move along the horizontal axis, which is the time in hours, as the profile decreases, that denotes that there's actually damage to the cells occurring and they're less viable. And then we calculate from those graphs what was the time that was taken to reduce the viability to 50% compared with the untreated control. And that's the ET50 value. And so in this particular case, we were able to identify a rank order of irritation using a linear extrapolation model, and we've shown the values in the table on the right hand side. And so this has shown that the most irritating surfactant is C, which is SLS, followed by SLES, followed by CAP-B, and then the mildest of all was in fact the novel biosurfactant. And this was very encouraging because this is actually what we expected to see in line with industry knowledge about these different surfactants.
So directly comparing, we used the same batches of materials and we diluted them down to 0.3% to apply onto the human volunteers. And what we saw was exactly the same rank order of irritation as was seen in the in vitro model. So we had 2 variants of SLS just as an internal control, and you can see those as the grey and the blue line. They produce a linear increase in skin irritation each day the product was applied. And then the SLES is next, and then you find that the biosurfactant and the CAPB are significantly milder ingredients. And so whether we measure erythema or we measure clinical grading, we get this you get the same results as we saw in vitro, which is very encouraging for the model.
So having had such an encouraging start, we decided then to look at some blends of different surfactants, knowing that these surfactants are actually used together in a wide range of applications in the industry. And a very common combination to be used is SLES with CAP-B, where formulators are aiming to get the formulation with the best texture while minimizing the irritation potential. So we looked at a number of different combinations. We haven't put the exact percentages in here today because we are actually preparing a peer-reviewed paper for a scientific journal on this topic, where we will be able to reveal all of that information. So apologies that we're not putting everything in today, but hopefully you can understand our reason behind that. But for this purpose, we are still able to show the rank order that we achieved of those surfactants, and it actually supported what we expected to see. And what we wanted to show was whether we got a direct comparison between in vitro and in vivo. So our rank order, just to keep in mind when we go on to look at the next slide, which shows the in vivo results, our rank order in vitro was C, A, B, followed by D.
And that was exactly the same rank order that we saw in vivo as well. So C, A, B, and D. Again, E is SLS, which is giving a high degree of irritation. It's much more irritating than any of the combinations of SLES and CAPB. But you can see that by changing the ratios, there's quite a difference that can be achieved in terms of the mildness of the formulation. And we've looked at other variables as well here in the way that you would typically formulate these, and that will form part of a paper that we're publishing, and we'll be sharing more of those results a little bit later when we've got more data, as Carol says. So there's a clear differentiation between the blends, with particularly blend C not being significantly different to E45 cream, a particularly well-known mild and innocuous skin cream. So that shows just how mild a formulation can be developed. The other thing that we wanted to do was to compare different ways of assessing skin irritation to look for an objective way of doing it. As I say, the way it's done primarily is with skilled nurses assessing irritation. We've looked at erythema and we've looked at skin temperature. And it was interesting that skin temperature also correlated well with the formulations, E being the SLS, the most irritating, and C being the least good of the CAPB SLES blends, and we see increased skin temperature at the irritated area, which was an interesting observation for us.
Having evaluated the test, looking at a number of single ingredients, so just looking at commonly used surfactants individually and in combination, we felt we were then ready to go on to look at some real life formulations and apply this work to what's really relevant to industry in terms of finished products. So one of the first studies that we did was to use some finished formulations that contain various mild surfactants. These were actually a range of shampoos. And in this case, we tested 3 different mild formulations against a pretty standard industry formulation, a fairly standard leading shampoo. And what we were able to show is that there was in fact a significant difference between these specifically mild formulations, which were all fairly similar to each other, and the standard formulation, which you can see in pink there, which was showing a much greater degree of damage to those skin cells within the model at an early stage of exposure. So we were pleased with the fact that this actually differentiated those effects from each other, and we came up with a rank order of irritation in vitro of D being the most irritating, and then fairly subtle differences between C, A and B. And we were quite curious to see whether those more subtle differences would be supported by the in vivo patch test data.
As Carol just said, actually, we found exactly the same rank order D, C, A, and B in vivo. All the samples were sent blinded by third-party collaborators on the project, and we only broke the codes. In fact, some of them we only broke this week. So it's all been done entirely double-blind, all this testing, both at XCellR8 and at Cutest. So it's really exciting to see just what a good correlation we're getting, even with these very mild products. What we saw with these particularly mild formulations compared to just dilutions of surfactant was the degree of irritation is much less, hence the more scattered lines that you've got when you look at the chroma. But this is where the instrumental measurements fell down. They were unable really to put the products in the right rank order because the difference wasn't very great between the variants. However, the expert nurses saw quite big differences in terms of irritation scores. So D, which was the standard product, was shown to be much more irritating than any of the other three formulations, and we put them in exactly the same order as XCellR8 did. So it's showing that the expert assessment of the skin is a more refined way than instrumental objective measures for seeing irritation, which for us was a slightly surprising, but also a very validating result for the expertise of our nurses.
Well, we've gone on since then to look at a number of different types of products, and one of the first ones that we looked at were a range of face masks with one of our collaborators. We feel that there's a really strong application for the skin mildness testing, particularly for products that are applied to the face and left on for a short time, such as these face masks. And so it was really interesting to compare these three to calculate ET50 values. And we were told after we had completed this study that this really gave more evidence to what the company had already suspected about these three different formulations based on some initial studies that they had done in vivo. Actually, they had previously done a few in vivo studies, and they had already demonstrated that C, which we have shown to be the mildest product here, was also shown to be milder, and they had a few formulation concerns that were subsequently addressed about A and B. So our rank order was B is B followed by A followed by C, but C stood out as being quite different.
And once again, this was the same rank order that we saw for the three face masks. Again, because these are so subtly irritating, these are not highly irritating products like you would expect from a surfactant. The chromometer again really failed to show the sorts of differences as clearly as the clinical examinations did. So we could see that there were differences in the formulations which were in the same order as we saw in vitro, again, which again is very encouraging for the correlation.
So we've shown you a flavour of the data that we've been getting for ingredients as well as finished formulations. And so we wanted today just to give a sample of that and then to think about the application of these kind of tests. And we hope that what we've shown quite clearly is that both methods provide really valuable claim support data for skin mildness, which we know is one of the priorities for the market in cosmetics and personal care today. And in addition, the in vitro screen could also be used as a prelude to clinical studies for either ethical or scientific purposes. For example, if there were suspicions about the irritation potential around a particular formulation, there are ethical reasons why it may be useful to screen that in vitro before going on to in vivo studies, particularly for baby care products, for example. But one of the key applications of this work is also on the marketing side in terms of brand differentiation, because we can provide some solid evidence about the mildness of an ingredient or a formulation compared with others that are available on the market. And I think one interesting thing from our perspective at XCellR8 as well is that this really helps to move the debate on from a fairly old statement now about products not being tested on animals, but taking that to a much more positive level by actually proactively adopting the latest non-animal technologies to demonstrate product safety and efficacy. Because we feel that consumers will always say, well, how do you test your products? And it's really important to be able to show that new techniques are actually better than any of the animal studies ever were for skin irritation. And so we're enabling brands to put out a positive message about the efficacy of the product, but also the fact that completely animal-free methods are being used. Now we can use this for ingredients. We've shown you some information today about novel biosurfactants. There are many of them out there, and it would be great to start to assess more of those and how they relate to traditional materials. And also we've looked at a wide range of formulations now to provide an in vitro database against which companies can benchmark their own products and see how they're stacking up against others in the market. And you can see there that I've listed a wide range of products, from soaps through to shower gels, skincare products, baby care products, etc. And the project has really enabled this database to get going, and it's something that we intend to continue with. You would have seen on the previous slide that we mentioned that we had used soaps and facial cleansers as part of this database, and we feel that this is a really exciting application of this project. This was an exercise that we did using a whole range of face soaps, and we thought that we would compare those with traditional facial cleansers. The reason we did this is that there's been a lot of information in the press and magazines recently about facial soaps coming back into fashion because they don't use plastic packaging. And we wanted to know whether those soaps are performing in terms of mildness compared to traditional cleansers. And we were able to tease out some really subtle differences. You can see the soaps on the left-hand side in the pink bars, and the facial cleansers on the right-hand side as the grey bars. There's a wide range of different ET50 values in both product groups. In general, the ET50 values are still greater for the facial cleansers, which means that in general, based on the data we have so far, they are still milder, which you might expect based on the formulations. But we can pick out some really interesting observations. For example, we had two products which were from the same brand, the soap and the cleanser, and we could show that the soap is considerably milder. And we had a wide range of prices, of price points for these products as well. And there's not necessarily a correlation between what people are paying for the product and how mild it is. So it was really useful to be able to compare some mass market products with some of those exclusive, niche, more expensive formulations. This is information that we are building on now, but we feel that this is going to be really useful for companies who come to us with a new formulation in product development to see where their product is performing compared to others that are out there already. So we'd just like to sum up the conclusions and future work that we're doing on this project. We've shown that the in vitro data accurately predicts the rank order of the human in vivo scores. And what's really been a great discovery for us in this project is that we've seen that agreement in all cases even when the differences between the formulations were very, very subtle, those same differences were seen in vitro and in the human in vivo clinical scores. So it's given us a lot of confidence in our in vitro model. What we'd like to do now is to grow the database to a wider range of products and also a greater number of products within each range, so we can expand on that benchmarking capacity of the test. And that is really critical to understanding what it all means in terms of applying real life industry data for new formulations. And we'd also like to widen the use of the model as a pre-screen for baby care products. So this can be done before moving into human patch tests. The test is now available. It's called Extra Mild, and it's now available for our client companies to use. So we're starting to actually provide some real life studies for this now.
And on the in vivo side, what's been really interesting for us and very validating, as I said previously, is that we've shown that actually when it comes to really mild products, the expertise of highly experienced dermatology nurses is better than the technical measurements we made of erythema and irritation. So that's really interesting in terms of how we develop these methods into the future. It was also important for us to see the link between the subtle signs of consumer relevant irritation, such as scaling, papules, spots, and these contribute to making an accurate assessment of how a product might be irritating the skin. And so being able to do this in such a systematic way across a wide range of product types is a real luxury that you don't normally get when you're doing commercial work. So to build up a database of information like this, as Carol said, is vital. We are publishing the research from this, so we are disseminating it more widely and in more detail, and there'll be lots more information as well that we haven't shared today, just to keep things straightforward for the webinar, so we didn't deluge you with too much data. So there'll be a paper on the optimization of the method, how we validated the approach that we were taking, and then we will cover some of the industry applications that we've shared and some others that we weren't able to share today. So there's a lot of information that we will be sharing, and we hope that what you've been through today has been of some value to you. I'd really like to say thank you for taking part in this webinar with us and listening to the work that we've done. And we'd also like to say a huge thank you to the companies which are on the screen here, because they've been collaborators with XCellR8 and Cutest in providing technical support, in providing products and formulations, and really helping us to robustly develop this system. It's been a really interesting research project, and I think both companies have learnt an awful lot from it in terms of skin irritation testing, which can only benefit consumers and the industry. And I believe there's a few minutes now where we're happy to take some questions. Thank you very much for listening.
Thank you very much indeed, Carol and Stuart. A really fascinating insight there with some great data. We had quite a few questions come through. First one I've picked out, will a higher pH level of soap affect the ET50 value? I don't know if someone wants to take the ball there.
Well, I think it's certainly one factor to consider. The majority of soaps are actually alkaline, and so what some of the formulators say is that by reducing that down slightly, that helps to make a milder product by bringing it slightly back down towards neutral or just below. So you might expect a slightly higher pH is more of a standard soap formulation. So they can have pHs, I believe, of around 8 or higher, and they are generally more irritating. So we would then expect to see a lower ET50 value, which means it's more irritating. But it's something we'd like to build on as we build the database.
Fantastic. Thank you very much for that. Are you able to share which biosurfactant was used in the study?
Well, we actually kind of blind coded that for the webinar because we felt that maybe it wasn't appropriate to reveal that without discussing that with the
Okay.
manufacturer. So I think that it's something that we might do when we publish the papers. We would like to, but we wanted to get, obviously it's good news for them, but we would
Yeah.
like to get their permission nonetheless. So I think I'll refrain for today if that's okay.
Understandable. Thank you very much. Well, we're getting lots of questions in now. Latest one we've got is, do you expect this method to be ECCVAM supported?
Well, I think that it's not necessarily relevant for ECVAM to be submitted to ECVAM because it isn't a regulatory safety test. It's based on the regulatory test, but it's designed for claim support, which is an area that ECVAM doesn't tend to get involved with. So obviously it's always nice if the guys from ECVAM approve of what we're doing because they're very, they're experts in the field, but formal accreditation is not needed for this model.
Okay. One of the questions I had was something that Stuart mentioned was that the human assessment was found to be more accurate than technological assessment during the study. How long do you imagine that to remain the case? How long will it take for technology to catch up there?
Yeah, I think it's a good question. It was a bit of a surprise to us because you think you're measuring very objective endpoints, skin redness, erythema. We have got other techniques that we can use on the skin which give different spectral imaging, for instance, which may give us different information, and it's certainly something we'd like to explore further. I think that almost certainly there's a way of getting better measurement data, but it really does tell you an awful lot about the human brain and the way it can see something which is very subtle on skin, and it can tell you more information than making a single measurement can ever tell you. And that's the same in any clinical application, really, is that people's expertise and ability to process complicated information appears to win out at the moment, which personally I think is good news for all of us.
Absolutely, yeah. It's very impressive. Back to Carol, you mentioned that you'd like to widen the database of benchmark products. Which product areas do you feel have most to gain from more accurate mildness claims, and what types of products would you like to test next?
Well, I think that we've got a very long wish list. It would be really nice to cover a lot, and we hope to build it up over time. But I think there's probably a priority there for skincare products and other products such as those face masks, which are applied to the face, because they are particularly relevant for mildness, especially things that are left on the face and not rinsed off. And clearly there's a big difference in those kind of formulations compared with shampoos, shower gels, etc., which contain surfactants by their very nature, so they're always going to be more irritating. And I think if we go to the really subtle end of the spectrum and look at those moisturizers and cleansers, etc., I think that would be of real interest to consumers. And obviously the baby care market is really of great interest as well, because that's where we could really add value by providing the pre-screen to the human tests.
And on the subject of pre-screening, if someone was within product development program, how would they use pre-screening? Would it not just make the process longer?
Yes, it would make the process longer. I think that there are decisions to be made about each formulation depending on what we already know about it. If there are some unknowns, do we need to be more cautious and go in vitro first? Just for reference, the in vitro tests take about 6 weeks to turn around. So if anyone's wondering how much it would add to the process, that gives an idea.
Okay, and if I go back to just getting some more questions in on the chat function, what is the likely impact of the dermis on skin irritation testing, as the model you used did not have a dermal component?
I think that's a really good question, Jill. I saw that coming in from you, so thank you for that. I think the process of skin irritation is in some ways simple, in some ways complex. I think there's clear primary effects on the basic health of the cells. Basic cell damage is a key component of skin irritation, and that's what we're modelling in the epidermis here. But we did actually start to look during the project, although we didn't talk about it today. We looked at the release of cytokines and some perhaps what you would consider even more subtle markers at an early stage of the irritation process before that basic cell damage occurs. And I think when we start to get into that further, we might want to then think about the role of a dermal component and how we get that crosstalk between the cytokines of the epidermis and the dermis. That said, I think that we have been able to tease out such subtle differences between these formulations just using the method that we have. And I think we need to balance that scientific curiosity with practicality and being pragmatic about what people are able to pay for these kind of tests, because including a dermis would necessarily increase the price of the screen.
Okay, thank you very much. I think we're running out of time a little bit now, so I think we'll wrap that up there. But I would just like to point out to everyone that registered and is listening, you should receive in the next 24 hours a replayable file of this presentation. So if you had any trouble logging in at the beginning and missed some of it, you should be able to catch up with what you missed tomorrow. But thank you everyone who attended, and again thank you so much to Carol and Stuart for a fascinating presentation.